Okay, here's your equation quiz review. And before we get started, I just want to point out I made a few notes over here on the right side that when we're solving equations, we want to do these couple of things. We want to first look to see if we need to distribute, so look for those parentheses and see if you need to use the distributive property. Then combine like terms that are on the same side of the equal sign. And then the ultimate goal would be to isolate the variable, use inverse operations, and then always remember that we keep the balance. Whatever we do to one side, we do to the other. So beginning our first equation, I don't see any parentheses, so there is not a distributive property here. The next step is combining like terms. So here I do see some like terms. 7x plus 8x. Pay attention to the sign that comes in front of those letters, or in front of those numbers as well. So 7x plus 8x, that's 15x. And then bring everything else down. Okay, now we have a two-step equation. So we've distributed, we've combined like terms, and now we're going to isolate the variable. So here is our variable, the x. Notice it's a 15 times x plus 5. Our next step would be to use inverse operations to isolate the variable. So since there's a plus 5 here, we're going to subtract 5 next. That eliminates the 5. And on the left side, we have 15x. And on the right side, we also have 15. Now this means 15 times x, so our final step, our final inverse operation is division. Divide both sides by 15. 15 divided by 15, that's 1x, which equals just x. And then on the right side, 15 divided by 15 is 1. So our final answer is 1. Let's follow the same steps to do the next problem. Okay, no distributive property because I do not see any parentheses. So our next step is to combine like terms that are on the same side. I see some right here. -3 minus 8. Be careful here with your negatives because -3 minus 8, that equals -11. So I bring everything else down. Next, we're going to isolate the variable. Here it is. It's x. This means 6x minus 11. So to isolate the variable, I need to clear out this 11 first. Keeping the balance, I do that on both sides of the equation. A minus 11 and a plus 11, that is eliminated. That becomes 0. On the left side, we have 6x. And on the right side, careful again here with your integers, -5 plus 11 equals 6. We've now reached our last step in isolating the variable. This means 6 times x. The inverse of multiplication is division. We divide both sides by 6, leaving us with 1x on this side. But remember in algebra, 1x, that 1 can become invisible. And 6 divided by 6 is 1. Oh, we got the same answer as the last one. Okay, moving along to number 3, following the same steps. Distribute first. I see distributive property in this example. Here it is. Look for the parentheses. This is a -8 times both terms inside the parentheses. So 216 on the left. Okay, -8 times 4. A negative times a positive is a negative. So that's -32x. And -8 times 1 is still -8. All right, now we are ready to isolate the variable. Here's our variable. It's -32 times x minus 8. So our next step would be to clear out the minus 8 by adding 8, keeping the balance on both sides. On the right side, a minus 8 and a plus 8 becomes 0, so that can be eliminated. 216 plus 8 is 224. And on the right side, we have negative 32x. Okay, so when the negative 32 is next to the x, that means multiplication. The inverse of multiplication is division. We will divide both sides by the negative and the 32. Make sure you take the negative with it. Eliminating over here, the negative 32 divided by negative 32 is 1x, which is simply x. And then 224 divided by negative 32, that equals a negative 7. Because a positive divided by a negative is a negative. Okay, so we got negative 7 for that one. And we got to use all the steps on that one. Okay, number 4, I think we're also going to use all the steps. We're going to distribute first because I see parentheses. So we're going to take this positive 7 and multiply it by both terms inside the parentheses. Okay, so I'm going to put my 5x here so I don't forget about it. 7 times 1 is 7. That's positive 7. And a positive 7 times a negative 7x is going to be negative 49x. And bring everything else down. Okay, so we distribute first. Next is combine like terms that are on the same side. I see some right here. We have 5x minus 49x. So 5 minus 49. That equals negative 44x. Plus 7, bring everything else down, equals 359. Okay, now we're on to isolate the variable. Okay, here's the variable. This means negative 44 times x plus 7. So I'm going to eliminate that plus 7 first by subtracting 7 on both sides. Okay, that essentially eliminates that because 7 minus 7 is 0. And so I have negative 44x equals 3. That brings me down to 352. Our final step is to use the inverse of multiplication, which is division. So we divide both sides by negative 44. Finally isolating that x by itself. And that gives me the x equals, let's see, so 352 divided by negative 44, which leaves us with negative 8 as our final answer. Okay, so that used all of our steps. Okay, moving along to 5 and 6. Again, I don't know if I mentioned this before, but if you're running out of space, just grab a piece of notebook paper. Don't try to cram it all in there. Take your time, write neatly. Okay, we're going to distribute next. Or first, our first step is to distribute. When I see those parentheses, I know I'm going to distribute. So 3 times negative x, a positive times a negative, that's going to be negative 21x. And 3 times negative 6 is negative 18. Okay, so step 1 is done. I used the distributive property to clear the parentheses. Okay, next up, I combine like terms on the same side. I don't see any. So we're moving on to isolating the variable. Here's the variable. So it's negative 21 times x minus 18. So I want to clear out this minus 18 first on both sides. Remember to keep the balance. A negative 18 and a positive 18 creates 0 pair, so that it gets eliminated. And now on the left side, I have negative 21x. And on the right side, be careful here because it's negative 165 plus 18, which is a negative 147. Okay, in our final step in solving, use inverse operations. The negative 21 is attached to the x by multiplication. So our final step is to divide both sides by negative 21. That eliminates that gets the x by itself, or becomes 1x. Remember, 1x is the same as just x. And then a negative divided by a negative is a positive. I'm going to do 147 divided by 21, giving us a positive 7 as our answer. Okay. All right. We have a new situation for number 6, or a different situation for number 6. Okay, looking at this one, I don't see any distributing. I don't see any parentheses. And I don't see like terms on the same side, but I do see variables on the same side. Notice how there's an x on both sides. So we want to isolate the variable. So let's get our letters together first. You can do this in either order. You can move the 4x to one side or the 6x to the other. I personally like to move the smaller x to join the bigger x. Okay, but you could do this the other way around as well. So I'm going to subtract 4x on both sides, eliminating my 4x's. On the left I have 5. Then 6x minus 4x is 2x. Okay, now we have a standard two-step equation where we need to isolate the variable. There it is. It's 2 times x plus 11. So I'm going to clear out the plus 11 first because I want to isolate that variable. Okay, so plus 11 and minus 11, that's nothing. That's 0 pair. And then 5 minus 11 is actually a negative 6. Be careful there. And then our final step, this is 2 times x, so the inverse of times is divide. So x equals negative 3. Okay, let's see. Oh, same situation here. I see we have x's on both sides, but I think something unique is going to happen here. Let's take a look. I want to move, both of the x values are the same. I want to move the smaller x's with the bigger x's. Let's see, so if I add 7x to both sides, this is unusual because a minus 7 and a plus 7x, that is 0. But on the left side, this is also going to be 0. So we're left with 8 equals 8. We're left with twins. 8 equals 8, that is a true statement. So when we're left with a true statement or a mirrored reflection or twins, twinfinite, this is called infinite solutions. And you may have recognized, even right looking back at the beginning, that both sides were the same. They were equal to each other. All right, moving on to the next one, number 8. I do see parentheses, so that indicates that distributive property. We have to do that first. Okay, so on the right side, 6 times 1 is 6, and 6 times 2x is 12x. And then I'm just going to rewrite this. Okay, so step 1 is done, distribute. Step 2 is combine like terms on the same side. I don't see any like terms on the same side, but I do see variables on both sides. Now, so we want to get our letters together. I like to move the smaller x value to join the larger x value. A positive 8x and a minus 8x, this goes away. That's eliminated. That becomes 0. So on the left side, I have negative 26. On the right side, I have 6 plus 4x. Because 12x minus 8x is 4x. Okay, we got it down to a standard two-step equation. So next we need to isolate the variable. Here's our variable. So we have to get rid of this 6 next. Since it's a positive 6, to get it to cancel out, I minus 6 on both sides. That is gone. Careful with your integers here. Negative 26 minus 6 is a negative 32 equals 4x. 4 times x. So this is saying 4 times what is negative 32? So our last step is to divide both sides by 4. Getting the x by itself. And that's going to give us negative 8. X equals negative 8. Okay, wow. This is a multiple step equation. Okay, same steps though. Do you see parentheses? I see them. Let's distribute first. So this 3 gets distributed between both terms in the parentheses. So I don't get confused, I'm going to bring this 2x down right away. And then 3 times x, that's going to be plus a 3x. And 3, don't forget to do 3 times 4, that's 12. And then write everything else down just to keep it nice and neat and balanced. Our next step is to combine like terms on the same side. And I do see that happening here. I have 2x and 3x on the same side. So I'm going to combine them next. 2x plus 3x is 5x plus 12. Okay, now I do notice that I have 5x's on both sides. This kind of should be a hint at something, but the constants are different numbers. So the x values are the same and the constants are different. I think this will end up being no solution. So our next step is to get our letters together. So I'm going to subtract 5x on both sides, and then here's where that unusual thing happens. A plus 5x and a minus 5x, that becomes nothing, but it also becomes nothing over here. So we're left with 12 equals 19. Well, no, 12 does not equal 19. That is a false statement. And if we get a false statement, then we have a no solution equation. There is no solution for this equation. Let's move on to number 10, a multiple step equation. And it looks like we have to distribute on both sides this time. But we can do it, We're going to go 3 times both terms here, and then this negative 6 gets distributed to both terms inside those parentheses. A 3 times negative 5 is negative 15x, and a 3 times a negative 7 is negative 21. And on the right side, a negative 6 times 1 is negative 6, and negative 6 times 3 is negative 18x. Okay, our next step is to combine like terms on the same side, which I don't see anything. So let's go ahead and isolate our variables. Notice we have variables on both sides, so let's get those together first. I like to move the smaller letters to join the bigger letters. Okay, over here a minus 18 and a plus 18 gets eliminated. That is nothing. Over here, a negative 15x plus 18x is 3x. And then bring everything else down. We're moving on to isolating the variable. Here it is. So our next step is to add 21 to both sides. This is eliminated. And I almost have the variable isolated. -6 plus 21 is positive 15. And then hopefully by now you know the last step. Divide by 3 on both sides. X equals 5. Whew, that was a big one. Okay, moving on. How many solutions does each equation have? So we're going to look for one solution, no solution, or infinite solutions. Okay, so same steps. I see that we're going to distribute first. So we multiply both things by 2 here. And that is going to be 2 times 4x is 8x. And 2 times -4 is -8. And oh my goodness, what do we have? A set of twins, right? When we have twins, it's infinite solutions. We still can go ahead and show how we get our variables together. So we minus 8x minus 8x, if you need to see that. That's gone and that's gone. So we're left with -8 equals -8. That's a true statement. So if we have a true statement, we say infinite, twinfinite solutions. When they're twins, it's infinite solutions. Okay, so make sure you showed it and you wrote infinite solutions. All right, next one. Okay, no distributive property, but we do have like terms on the same side. Right here, pay attention to the signs in front of it. So 3x, -3x plus 7, that's going to be 4x plus 1 minus 12 equals 5x minus 11. And I also see that we can combine right here, same like terms on the same side. So 1 minus 12 is -11. So this simplifies to 4x minus 11 equals 5x minus 11. Okay, now we're going to isolate the variables. When there's variables on both sides, I like to move the smaller letter to join the bigger letter. This is eliminated. And this becomes 1x minus 11. Okay, now we're going to add, isolate the variable. Here's the variable, so we're going to add 11 to both sides. And that becomes 0. Okay, so that cancels out, and oh my goodness, we're going to get 0. That's okay though. -11 plus 11, that's 0, equals 1x. And then remember, if it's just 1x, we can just say that's x. Or you could divide by 1 on both sides, we still would get 0. So our solution is 0. So we do have one solution, and the answer is 0. Okay, and finally, the last one here in this set. Oh, I wonder if we should also write one solution. Let's do that for that last one. One solution. Okay, and here we go. We have variables on both sides. I like to move the smaller variable with the bigger variable, but they're actually the same. So we do -6x on both sides. And this is where something special happens. That becomes nothing, and that becomes nothing. And it's like they're almost twins, but they're not. These are not twins. 5 is not the same as -5. This is a false statement. And if we get a false statement, then we say no solution. Okay. So there we have that set. So it's infinite for the first one, then one solution, and then no solution. Okay, so for the next set, we're going to define the variable, write an equation, and show our work to find a solution. An apartment complex needs 2 months' rent and a $500 deposit when signing a lease. The total amount paid was $2,800. What is the rent for 1 month? So X is our rent for 1 month, because that's what we're looking for. Okay. So our equation. Well, I do see our total amount. So we know, we can always set our equal sign to the total. And then we have a 2 months rent and a $500 deposit. So deposit is what you put down first. So that's like our initial value, and we need 2 months rent. So we know our rent is X. So we need 2 of the rents and a $500 deposit. So this is what our equation would look like. And I probably should have highlighted that those terms in there. Okay, so let's follow our steps. There's no distributed property, there's no combining like terms, but we are going to isolate the variable like we've been doing. So we do our inverse operations. So let's subtract 500 on both sides first. Okay, so that eliminates our 500 on the left side. Bring down your 2x. And then our last step, the inverse of multiplication is division. We're going to divide both sides by 2. So 2,300 divided by 2 is 1,150. So 1 month's rent, our solution for 1 month would be $1,150. For rent, yes, folks, things get expensive when you're renting. Okay, same steps here. We're going to define the variable, write the equation, and show the solution. Lynn walks dogs for a summer job. She offers clients 2 options for paying for walks. Option A, you pay $10 and $1 per mile. Or option B, where you pay $4 and an additional $2 per mile. At how many miles would the cost be the same? How many miles would they cost the same? Okay, so that's where and the question is where we can get our variable. How many miles would the cost be the same? So we're looking for the number of miles. So that will be our variable. Okay, now this is a little different. We have 2 options, and we're trying to figure out when option A is equal to option B. Okay, so we're looking for option A compared to option B. So option A, again, was you pay $10 and $1 per mile. In option B, you pay $4 plus an additional $2 per mile. And then we solve from there. So we have variables on both sides. Do you see them? So let's get our letters together first using those inverse operations. I'm going to move the smaller letter to the bigger letter, just the way I like to do it. And on the left side, we're left with 10. And on the right side, we're left with 4 plus 1x. Okay, continue isolating the variable. So here, our variable now is on the right. So I'm going to clear out this 4 first. And that leaves us with 6 equals 1x. Because a 4 and a minus 4 cancel it out. And then 1x is the same thing as just x, or we could divide by 1 on both sides. And we're left with x is 6. So our solution is the cost would be the same at 6 miles. Okay, so that one was a little different because we had two situations that were equal. We were trying to find out when they were equal to each other, so that's why it's set up that way. And then you use your equation solving skills.